Hello friends, good evening, welcome to NEET World. So, this is your Abhilash sir, mathematics faculty for EAP set, KSET, JEE and also for foundation. So, continuing with our previous session, in the last class we started with the introduction to number system. So, we will be continuing with the number system chapter itself. So, today in this chapter we will be starting with what is called rational numbers. In the previous class where I gave the introduction, we learnt what is a real number, then we learnt if you add 0 to that it becomes whole number, and then also we learnt what is an integer. For the whole numbers, if I add negative numbers then it becomes integer. Then we learnt what is rational number, where we learnt a number which can be expressed in the form of p by q, where q is not equal to 0. That is a property of rational numbers which we learnt. Now, when it comes to rational numbers, some more important properties which we have to learn. So, when it comes to rational numbers, there are two things which you have to keep in mind. Suppose, let me take one example. See here. Suppose I divide 7 by 2. How do we divide it? We can write it as like this, 2 3s are 6, okay. You will get 1. I have to put what? Decimal point. So, this will become what? 0. So, this will become 2 5s are 10. So, you will have 0, right. Now, when it comes to this, what we got? 7 by 2 can be written as what? 7 by 2 can be written as 3.5. So, we got it as what? This decimal is nothing but what? We got it as terminating one. Terminating one, okay, that is what it already ended at 3.5, it did not continue, that is what it is terminating. Suppose I take another number, another fraction, this is what p by q form, another p by q form. If I take another example, see here, if I take 10 by 3, so if I have to divide 10 by 3, what I will get? See here, so 3 3s are 9, I will get 1 remainder. Now, if I take decimal point, I will get 0, so I should take 3 3s are 9, again I will get 1. Similarly, already I took decimal point, I should put 0, and this will become 3 3s are 9, this will go on like this. You will get 3.33 something like this. So, you will get it as what? 10 by 3 you will get it as 3.333 like this, it goes on, okay, it goes on like this. That is what? It is not terminating, but it is repeating itself, it is repeating itself. Instead of writing 3.333 again and again, you can represent it as what? 3.3 bar, that is nothing but bar, it is coming again and again, that is 333, it keeps on coming, that is it is repeating. So, what is this called? These numbers are called, this is non-terminating, this is non-terminating, and it is also what? It is non-terminating and repeating, it is non-terminating and repeating, okay, it is non-terminating and repeating. See, this can be written as what? 3.3 bar. Suppose I have something like this, see here 7.13 bar, this can be written as what? This can be written as 7.1313, 1313, 1313, 1313, it goes on like this. That is 13 repeats itself again and again. Suppose I write 4.17 bar, 4.17 bar, only bar is for 7. So, this can be written as what? 4.177777, it goes on like this. So, that is the meaning of this 4.17 bar. So, if I write it as 4.17 whole bar, okay, it cannot be bar just for one, okay, it should be for entire thing here. So, this will become 4.17171717, it goes on like this. Or if you put it as 4 point, you might be having a doubt, 4 point bar only to 1 and 7, it is written like this. Such a number does not exist, such a number does not exist at all. So, here what we have? Rational numbers. One is it is terminating, another one is it is non-terminating and repeating, okay, it is non-terminating and repeating. So, this is the meaning of rational numbers. So, what are the properties we learned? One is it is terminating, rational numbers are terminating, and rational numbers are also non-terminating and repeating numbers, okay. These are the two properties you have to keep in mind, friends, okay. Students, you have to keep in mind, that is it is terminating and also it is non-terminating but repeating, okay. That is the meaning of rational numbers. These are the two properties you have to keep in mind. What did I say? So, rational numbers, okay, they are terminating, another thing is they are non-terminating but repeating. non-terminating but repeating itself. They keep repeating itself. Okay, they are terminating, non-terminating, repeating itself. Example I can write it as what? I can write it as 3.5. This example I can write it as what? I can write it as example 3.5 is nothing but 7 by 2. This here I can write it as what? 10 by 3. This is nothing but equal to what? 3.33. 333. It keeps on repeating. Dot means what? It is keeps on repeating itself. Here I have noted down dot because it is not terminating. It is what? It is terminating. Here it is non-terminating, so I have written dot. Here it is terminating, no need to write dot. It is ending itself. Is it clear? So rational numbers, two properties, terminating and non-terminating. So here you have to understand one thing. All terminating numbers are rational numbers. True or false? Yes, absolutely it is true. All repeating or non-terminating numbers, repeating and non-terminating numbers are rational numbers. Yes, are they rational numbers? Yes, absolutely it is true. But all rational numbers are terminating. Is it a true statement? No, because it is not a true statement, because rational numbers need not be only terminating, they can be non-terminating and repeating also. Another statement, all rational numbers are non-terminating and repeating. No, you cannot say like that. All rational numbers cannot be like this. All rational numbers cannot be like this, because some rational numbers can be terminating. So rational numbers can be terminating, or rational numbers can be non-terminating and repeating. Okay, if it is non-terminating, definitely they should be repeating. Okay, but this way it is true. Okay, all terminating are rational numbers, all non-terminating and repeating are rational numbers, but all rational numbers are not terminating, all rational numbers are not repeating. Okay, so this way it is not true, but this way it is true. This way it is true. That is, rational numbers are only repeating? No. Rational numbers are terminating also. Rational numbers are terminating? No. Rational numbers are repeating also. All terminating numbers are rational numbers? True. All repeating numbers are rational numbers? It is a true statement. Is it clear? I hope it is clear. Now, till now we have learnt about what is rational numbers. Now, we will learn another type of number that is called as what? Irrational number. Till now we learnt rational numbers. Here we will be learning irrational number. Irrational number. So, irrational number means what? The word itself says whatever which is not rational, that is whatever which is not rational or irrational number. Rational number is what? It is terminating. Okay, rational number is what? It is repeating. Which is neither terminating nor repeating, it is irrational number. So this is what? It is neither terminating, nor repeating. Okay, it is neither terminating nor repeating, it is irrational number. It is neither terminating nor repeating, it is an irrational number. Example, see here, I can write it as 1.10010001000001. It goes on like this. Dot means it is not terminating. Dot means what? It is not terminating. I am writing like this. It is not repeating. See here we are having double 2 zeros, here we are having 3 zeros, here we are having 4 zeros. That is, it is not repeating. But here what happened? See here friends, here it is repeating 3 3 3 3 3, it is repeating. Here it is 1 3 1 3 1 3, it is repeating, and it is non-terminating. It is repeating. But here you cannot count this as repeating. Here there are 2 zeros, but here there are 3 zeros. It is not same. Here there are 4 zeros. It is not same. Okay, it is not same as 2 zeros. So here it is non-repeating, and it is what? It is non-terminating. It is neither terminating nor repeating. It is not terminating also, it is not repeating also. It is neither terminating nor repeating. There it was terminating and repeating. There it was terminating and repeating. Okay, there it was terminating and repeating. Here it is neither terminating nor repeating. Clear? Another example let us take. Suppose I write 2.20222, again 1 2 2 3 0 0 2 dot dot dot. See here, no numbers are repeating. In the sense, there is no pattern, set pattern. 2 0 0, again 222, 1 2 2 3 0 0 2 0. There is no set pattern for this. So that's why it is neither terminating. Dot 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 means it is neither terminating, and it is not repeating also. That's why it is what? Irrational number. This is one of the property. Another property is what? It should not be a perfect square. It should not be a perfect square number. Not a perfect square. Not a perfect square. So if I talk about perfect square, see here, if I talk about what are the perfect square that we have, 1 is a perfect square of itself, okay, 4 is a perfect square, that is it can be written as 2, okay, 9 is a perfect square, it can be written as 3, 16 is a perfect square, it can be written as 4, okay, 25 is a perfect square, it can be written as 5, Okay, so apart from these numbers, okay, apart from these numbers, what are all the square root that we get? That is what? 1 is a perfect square. I cannot use it. So root 2, root 3, okay, root 5, root 6, root 7, okay, root 8 I am not writing. Just in a moment you will get to know why I am not writing root 8. So please observe, please focus. So what about root 9? Root 9 is nothing but 3. That is a perfect square. 3 can be written as what? 3 by 1. This is a rational number. P by Q form. 1 by 1. This is 4 by 1. This is 5 by 1. This is nothing but what, friends? This is P by Q form. So that is why I cannot write it as an irrational number. This is a perfect square. They are asking not a perfect square. It is not a perfect square means it is irrational number. What about root 10? Yes, it is. Yeah, it is not a perfect square. Root 11, root 12, okay, root 15, like that. Next thing, another property is it should not be a perfect cube. One is what? Not a perfect square. Another thing is what? Not a perfect cube. So that is not a perfect cube. Not a perfect cube. So what are the perfect cubes that you have? So 2 cube is nothing but 8. So cube root of 8 is, or cube root of 1 is nothing but 1 itself, 1 by 1. Cube root of 8 is 2. I can write it as 2 by 1. Cube root of 27 is nothing but what? 3. I can write it as 3 by 1. And cube root of, next what you have? 64 is nothing but 4. Okay. So that can be written as 4 by 1. So not a perfect cube means I cannot use cube root. This is cube root, right? I have to write 3 here. Okay. So I cannot use cube root of 8, I cannot use cube root of 27, I cannot use cube root of 64. Apart from this, except perfect cube, I can use any other numbers. So I can use what here? I can use cube root of 2, cube root of 3, cube root of 5, okay, cube root of 6 or cube root of 11, like that. These are all what? These are all irrational numbers. Along with this, another number, that is fourth property, that is another number that is an irrational number, is pi. Pi is also an irrational number. Why pi is an irrational number? This you will understand when I do mensuration. When I do mensuration, surface area, volumes, all this chapter when I do, why pi is an irrational number, there I will explain. But as of now, first thing what we did start? We started with natural numbers, then whole numbers, then integers, then rational numbers. In rational numbers, it should be of the form P by Q form, where Q should not be equal to 0, and based on that we solved an exercise, that is exercise 1.1. Now going forward, when it comes to rational numbers, there are some properties, additional properties which you have to learn. One is it should be terminating, which we saw. Okay. Another thing is it should be repeating. It is, if it is not terminating, it should be repeating. Okay. So we saw some examples. Now when it comes to, apart from rational number, there is another kind of number that is called irrational number. Irrational numbers are those numbers which are not rational. So what are the properties that they have? That is, it is not terminating. Okay. They are neither terminating nor repeating. That is, they don't terminate or they don't repeat. So that is, these are all the examples that we saw for that one. Okay. Next thing is, it is not a perfect square. They should not be a perfect square number. That is, square root of 2, square root of 3, square root of 5, square root of 6 is fine. I didn't write square root of 4 because it is a perfect square. I didn't write square root of 9 because it is a perfect square. I didn't write square root of 16 because it is a perfect square. Similarly, I didn't write square root of 25 because it is a perfect square. Similarly, I didn't write square root of 36 or square root of 49 because it is a perfect square. So, likewise, it should not be a perfect cube. That's why I didn't write cube root of 9, or I didn't write cube root of 8, cube root of 27, cube root of 64. Okay, like that I didn't write because, or cube root of 125 I didn't write because they are perfect cube. Apart from that, whatever numbers I wrote, they are not a perfect cube. They are all irrational number. Apart from this, apart from 1 to 3 properties, there is fourth one, that is pi. Pi is also an irrational number. This much understanding you need to have, friends, when it comes to irrational number. Now going forward, another thing which you have to know is, when it comes to, there is another set of number, that is which combines both rational and irrational number, that is called real numbers. That is called real numbers. Real numbers are what? They are an umbrella set, that is nothing but what? They are containing rational numbers also, and they are containing irrational numbers also. Okay, they are containing rational numbers also, they are containing irrational numbers also. So if I use a statement, all rational numbers are real numbers, absolutely true statement. All irrational numbers are real numbers, absolutely true statement. But the other way around, it is not true. all rational numbers, all real numbers are rational numbers? No, because even irrational numbers are real numbers. All real numbers are irrational numbers? No, it is not true, because it includes rational numbers also. But what is a true statement? All rational numbers are real numbers? True. All irrational numbers are real numbers? It is true. This way around it is true, this way around it is true. Clear? This much understanding you need to have when it comes to real numbers, rational numbers and also irrational numbers. Okay. Now, based on this understanding, let us solve some question which is given in your exercise, that is exercise what? That is exercise 1.2. Okay, look at the exercise. They have given, state whether the following statements are true or false. Okay, justify your answers. They are asking, first question is what? Every irrational number is a real number. Every irrational number is a real number. Just now we saw. See here. Every irrational number can be an irreal number. Yes, it is a real number. Yes, because irrational numbers comes under set of real numbers, because all irrational numbers comes under the set of real numbers, because real numbers are a bigger entity. Next statement, they are telling every point on the number line is of the form. Okay, before that let us see third question. Look at the third question. They are telling every real number is an irrational number. Every real number is a real number? No, it is no. Why? Because every real number is not an irrational number. Every real number is not an irrational number, because it contains even rational number. Because why? Because real numbers contain even rational numbers along with irrational number. Okay, every real number is an irrational number. It need not be true, because real numbers also contain rational numbers along with irrational number. That is what we saw here. See, if they ask a question that every rational number is a real number, it is true. Every irrational number is a real number, it is true, which is a question that is asked. But if they ask every real number is a rational number, it is false. Because it contains irrational also. Every real number is an irrational number, it is false, because it contains rational number also. Okay, that is a statement we learnt now. Now let us have a look at the second statement. That is, they are telling every point on the number line is of the form root m, where m is a natural number. They are telling where m is a natural number. Okay, so here we have to represent a number line. See, about the number line you already studied in class 8. So when it comes to number line, we know that, suppose I write the number line here. If I write 0 here, 1, 1, 2, 3, 4, 5, something like this. Here it will be minus 1, minus 2, minus 3, minus 4, something like this. The answer is no, because see here, this square root of 0 is nothing but equal to 0 itself. Square root of 1 is equal to 1 itself. Square root of 2 is square root of 2 itself. Okay. Square root of 3 is square root of 3 itself. Square root of 4 is 2. Square root of 5 is 5. Square root of 5. Okay. Now what happens? Every point on the real number, every point in the number line is of the form square root of m, where m is a natural number. Yes, it holds true when it comes to 0 and also these natural numbers. But when it comes to negative numbers, you cannot write square root. You cannot write square root for negative number, because square root of negative number does not exist. It is not a natural number. It is not at all a real number also, because these are some other number called complex number. Okay, square root of a negative number, it is not a real number itself. It is not a natural number. It is not a whole number. It is not an integer. It is not a rational number. Okay, it is not a rational number. It is not even a real number. Square root of a negative number does not exist, or you can say that it is not a real number. It is another number that is called complex number, which you will study in when it comes to class 11th and class 12th. That is square root of negative number, negative 1 or square root of negative 2, we call it as complex number. Okay, complex number. Okay, which is not a real number. No, because square root of negative numbers cannot be expressed in the form of square root of m. Okay, because square root of negative numbers cannot be expressed in the form of square root of m, where m is a natural number. Okay, clear? It is not a correct statement. So the answer is no. Okay, the answer is no. That is, it is false. Yes or true? This is false. Here also it is false. Okay, no or false. Okay, I hope it is clear, this question. Let us move to the next one, friends. Look at this. What is the question that they have given? They have given, okay, are the square roots of all positive integers irrational? Are the square roots of all positive integers irrational? No. The answer is no. Are the square roots of all positive integers irrational? No. Because perfect squares are not irrational, because perfect squares are what? Rational numbers. Because square root of 4, example, square root of 4 is equal to 2, I can write it as 2 by 1, comma, square root of 9 is equal to 3 by 1 is equal to nothing but 3 by 1, I can write it as 3 by 1. Okay, square root of 16 is equal to 4 by 1, etc. are not irrational. They are what? Rational numbers. Are not irrational. They are all what? Are not irrational number, because they are already what? They are all perfect square. Perfect squares are not irrational number. Okay, square root of every positive integer, they include even perfect squares. They include even perfect squares. So they are not irrational number. So every positive integer, no. Okay, because they include every positive integer. Square root of every positive integer means they are including the square root of perfect squares also. That is square root of 4, square root of 9, square root of 16, 25, square root of 36, square root of 49, square root of 81, just like that. Okay, square root of 100. They are all what? They will give us the rational number. So they are not irrational number. Is it clear? If not, give an example of the square root of a number that is a rational number. Example we have given so many example. I hope it is clear. That example itself is the reason for this. Clear? Okay, I hope this question is clear. Let us move to the next one, friends. Okay, let us move to the next one. Now what they are telling? They are telling, show how root 5 can be represented on the number line. They are asking how root 5 can be represented in the number line. So this construction and all you already learned in class A. Okay, but before going to root 5, let me teach you how to represent root 2 on the number line. Let me teach you how root 2 on number line. After that root 3, then we will go for root 5. In this class, let me teach you root 2 on the number line. Using that, please try to do root 5 by yourself. In the next class, I will be doing it for you. Okay, root 2 on the number line. How to represent root 2 on the number line? See here. First of all, draw a straight line. Take this point. Okay, take this point. Let this point be A. Okay, from here, take a distance of 1 centimeter. Okay, let this point be B. Okay, at point B, you need to take 90 degree. So to get 90 degree, you will draw an arc here. Okay, from here you will keep a compass and you will draw on this one arc here. You will keep the compass, you will draw this arc here. You will keep here and you will draw an arc here. You will keep the compass here and you will draw an arc here. Okay, now if you join this, you will get actually, just a minute. You will draw an arc here and you will draw an arc here, and if you join this, you will get something called a straight line. Now keep the compass here, measure 1 centimeter, keep the compass here and your measure and draw an arc of 1 centimeter. You draw an arc of 1 centimeter. So this is 1 centimeter. Okay, let this be point C. This also, it will be 1 centimeter. Okay, this will also be how much? This will also be 1 centimeter. This will also be 1 centimeter. Now join this AC. Now by Pythagoras theorem, you already got a triangle. In triangle ABC, okay, angle B is equal to what? Angle B will be 90 degree. Angle B will be equal to 90 degree. So by Pythagoras theorem, I'll write it as by Pythagoras theorem. Again I will explain. Take this point A and point B with this width 1 centimeter. From here at point B, construct 90 degree. So you draw an arc. Then from here you draw one arc. From here you keep the compass, draw an arc. Then keep it here one more arc and keep it here one more arc. Join the line, you will get a straight line. Now from here keep the compass, measure 1 centimeter and draw an arc. So join this line. So then again you will get, let this point be C, you will get BC as 1 centimeter. Now by Pythagoras theorem, in triangle ABC, angle B is equal to 90 degree. So AC square is equal to AB square plus BC square. If I put the values, I will get it as AC square is equal to 1 square plus 1 square, that is equal to AC square is equal to 2. So, AC will be equal to what, friends? AC will be equal to root 2. AC will be equal to root 2 centimeter. So, we got AC is equal to what? Root 2 centimeter. Okay. We got AC is equal to root 2. They are asking us to what? This AC we got it as root 2 centimeter, but they are asking us to represent root 2 on the number line. To represent root 2 on the number line, please keep the compass here, okay, and measure till here. Keep the compass and measure till here. That length will become what? That length will become equal to root 2. So, from here, using the compass, draw a dotted line. Okay. Just a minute. So, draw a dotted line using this. So, if you draw a dotted line using the compass, you will get it like this. Get a dotted line like this. Okay, we will get a dotted line like this, and this point, at this point BD, this point is nothing but equal to root 2 centimeter. This is nothing but equal to root 2. Okay, this point will be nothing but equal to root 2. This point which you get here, this will be root 2. That is how root 2 is represented on the number line. That is how you represent root 2 on the number line. I hope it is clear. Okay, I hope it is clear till here. Now, I hope it is clear. Now, the homework for you is please represent root 3 and also root 5 on the number line. Root 3 and root 5 on the number line, friends. Okay, I hope you will be able to do it. Okay, this will be a homework for you. In the next class, I will be doing it in the class itself. But in the previous class, I had given a homework. Okay, that is in the previous class, I had given a homework, but I asked you to find, I think 5 or 6. Let me take it as 5 itself. 5 rational numbers, 5 rational numbers between 1 and 2. 5 rational numbers between 1 and 2. So, we have to take it as what? 5 rational numbers between 1 and 2. So, this is what? Here n I should take it as what? The number of value, that is n should be equal to 5, and first number I should take it as x. First number is x, this will be x, and this will be y. So, here x is equal to what? 1, y is equal to what? 2. Then I told you our star step, that is you have to find the value of d. For d, what we use? The formula we will use is d is equal to y minus x by n plus 1. Y minus x by n plus 1. This is our star step. Okay. This is our star step. So, using this, we will find out d. So, d is equal to what we will get? Y minus x is 2 minus 1 by n plus 1. N is 5 plus 1. Okay. 2 minus 1 is 1. 1 by 6. 5 plus 1 is 6. So, we got d. They are asking 5 rational numbers. So, that will be what? First number we have to add to the first number, that will be x plus d. Next is x plus 2d. Okay. Next thing is what? X plus 3d. Then x plus 4d. Then x plus 5d. So, 5 rational numbers is you should have to find up to x plus 5d. 10 rational numbers means x plus 10d. 20 rational numbers means up to x plus 220d. Okay, like that 20d. So, x plus d means this is what? X is what? 1 plus this is 1 by 6. So, if I take the LCM, I will get 6. This will be 1 6 is 6. 6 plus 1. 6 plus 1 is 7. 7 by 6 I will get. So, this is 1 plus 2d. 2d means 2 by 6. Don't cancel, write just it as 2 by 6. So, LCM will be 6. So, this will be what? 6 plus 2, 8 by 6. Now, you can cancel here. So, this will become what? 2 4 is 4 by 3. Okay. Now, x plus 3d. So, this will be 1 plus 3 by 6. So, LCM if I take, this will be 6. Okay. So, 6 plus 3, 9 by 6. If I cancel here, this will become what? This will become 3 by 2. This will become 3 by 2. So, this will be 2 4 is 2 3 is 4 by 3. Okay, done. Now, if I take this, this will be x is what? 1 plus 4d. 4d means 4 by 6. So, if I take LCM, this will be 6 will be the LCM. So, this will be 10 by 6. So, if I cancel this, 2 5 is 2 3 is, that is cancel means if I simplify this. Now, x plus 5d, that is 1 plus 5 by 6, that is if I take LCM, 6 will be the LCM, this will be 6 plus 5. So, I will get it as what, friends? 11 by 6. So, the 5 rational numbers, you have to write it. The 5 rational numbers between 1 and 2 are, between 1 and 2 are, we got 7 by 6. After cancelling, I got it as what? 4 by 3. Next, I got what? 3 by 2. Next, I got what? 5 by 3. Next is 11 by 6. This is how you solve this question. These are the 5 rational numbers between 1 and 2. I hope it is clear. So, today we learned the very important properties when it comes to rational numbers. For rational numbers, they should be terminating, and also if they are not terminating, they should be repeating. For irrational numbers, they are neither terminating nor repeating. we learned some examples, then they should not be a perfect cube, they should not be a perfect square, and pi is another number which is an irrational number. All these things we learned, and also we learned how to represent root 2 on the number line. I have given you homework, root 3 and root 5 you have to represent on the number line. Okay, please watch that introduction class, that is the previous class, then only you will be able to understand this class. Okay, so please follow this session. We'll meet you tomorrow again at 6 p.m. Thank you friends. Let's wind up today. Let's meet in the next session where we'll be continuing with this number system itself, where I will be representing root 5 on the number line, and then we'll continue from there onwards. Thank you friends. Take care. Please keep practicing.